Good day everyone. I'm here to discuss to you my solution on the pre-midterm examination problem number 3. We have here the problem to determine the design moment strength of the T-beam shown in the accompanying illustration if Fc prime is equals to 28 megapascal and Fy is equals to 420 megapascal. Given the width of the flange, effective width is 800 mm, the flange thickness is 100 mm, the effective depth to the tension bar is 800 mm, the width of the web is 400 mm, and Fc prime is 28, Fy is 420 megapascal, and we have here 832 mm bars. First is to compute the steel area. We have 832 mm bars. So for the formula in finding of the area of steel, we have here pi over 4 times its diameter and times its number of bars. So we have the value of area of steel, which is equals to 6,433.98 mm squared. And for the value of our beta 1, we have 0.85. Now, let's compute for the area of the flange of the beam. So we have here 800 for the effective width of the flange and multiply it by its flange thickness. Now we obtain the area of flange equals to 80,000 mm squared. Assuming the tension steel will yield, we have the compression of concrete equals to the tension. The equivalent formula for C sub C is 0.85 Fc prime AC. And for the tension, we have AS Fy. Since the value of Fc prime, Fy, and As are known, we can solve for the value of the area of compression concrete. And we have obtained that the value of AC, or the area of compression concrete, is 113,540.82 mm squared. As we can see, it is more than the area of the flange. The area of the flange is 80,000 mm squared. The required area of concrete is 113,540.82. Obviously, A here overpass the area web. This will be the location of A. Now, let's divide the concrete area. Subtract the width of the web to the width of the flange so that we can obtain the width of the two rectangular form beside the A. Now, let's compute for the value of A. We have here the formula AC equals to 400 times A plus 200 times 2 times 100. Substituting the values, we have here the value of A as 183.85 mm. Now that we have our A, let's compute for the value of C to check if it yields. So we have here the formula for the value of C is which is equals to A divided by beta 1, and it resulted as 216.3 mm. Next is we have to compute for the stress of the steel here. We have the formula of Fs, which is equals to 600 times D minus C over C, and substituting the formula, or the values, and that will give us the value of Fs equals to 1619.14 MPa, meaning our assumption is correct and it thus yielded. Aside from that, This is attention controlled because of the value of our Fs is more than 1000 MPa. The strain also is more than 0.005 if we divide it by 200,000. Since it is more than 100,000 MPa, the reduction factor here is 0.90.